Good morning, everyone. This is the ACE session. If you are not here for ACE, you should probably reconsult the agenda and find a different room. We currently do not have any volunteers for minutes or Jabber Scribe. Do we have any volunteers now? We have a volunteer for Jabber, so we still need some minutes. Excellent. Just in the Etherpad, or? Oh no, Jabber already got claimed. And I will start the blue sheets around. I need to pull up the Etherpads. Yeah, you presenting. Do we have indicators? I think, if we do it in the Etherpad, then we can have.
Yes, I'd like to second.
Yes, please.
Yes, please. Yes, please.
Thank you, Nancy, for volunteering to be co-minute takers. So if you go to the main agenda, then there's those little icons to the right of each working group name. And there's a little pen. Okay, and if we do have remote people, could you just confirm in the Jabber room that you can hear us? Excellent, we have confirmation from the Jabber room. So I think we should probably get started. So, hello everyone. We are the new co-chairs. So, should we go to the next slide? Of course, we have the note well. Hopefully, everyone has noted well already. Okay. Yeah, the mic seemed very live earlier, so I was keeping it far away. But yes, everyone should note the note well. It's also available online if you use your favorite search tool to search for IETF note well, you will find it. So on to the next slide with the agenda. So we did make a couple of small changes last night. So if everyone has had a chance to review the agenda, has proposed changes, other things they want to talk about, please come up to the microphone now. All right, barring that, let's keep going. So we'll start off with a status update. First off, the faces at the front of the room are a little bit different. So hi everyone, I'm Ben, and you probably know Jim as well. And in terms of document progressing, hopefully everyone saw that the CWT document is now in working group last call. We gave it a couple extra weeks because the last call period does overlap with both this meeting and the U.S. Thanksgiving holiday. So please get your comments in by the 29th of this month. And we also had the adoption call for the OSCOPE profile, and we have concluded that it is adopted. So if the authors of that could go ahead and submit the next revision with the IETF ACE namespace, we can get that approved and marked in the data tracker properly. And now we need to change over to Mike. Come on up.
Good morning. I'm Mike Jones from Microsoft, and I'm here on behalf of my co-editors to talk about two closely related drafts. The first is the CBOR Web Token, which Ben was just mentioning, which is used by, among others, ACE OAuth and some other work, including work outside the IETF. So we're at draft 9. There was a first working group last call on draft 7 before we last met our heroes. Since then, what's primarily happened is people gave us substantive feedback on the examples, and that was incorporated. Mostly, there's now much more extensive of CBOR diagnostic notation. The technical content of the examples hasn't really changed, other than we added key IDs so that those could be referenced. I will say that, and this has happened on the list, so you're probably already aware of it, but there have been multiple independent validations of the technical content of the examples. So while at 99 we weren't sure they were correct, we now have multiple independent confirmations, so we have high confidence that they are correct. And as Ben mentioned, we have a second working group last call underway until near the end of the month. One issue has been identified in current reviews so far. This may have been Hannes, or Hannes was a commenter on this, that the current language describing the audience claim is ambiguous. The intent was to say that audience values are of type string or URI, and it does say the structure is exactly parallel to JOT. Where JOT, it can be an array of audience values, and that was the intent here. But if you were reading this draft and you weren't already intimately familiar with JOT, there's a misinterpretation possible. I believe it's already in theory correct as it stands, but we owe it to people to make it unambiguous when read standalone, so we will do that. I think this is my last slide. My main request is that during the second working group last call, people do a thorough review, particularly those of you with implementations. I mean, editorial feedback is always great, but if you've built this and as you've read the spec, you came up with things that seemed, or you had to make a judgment call or whatnot, this is exactly the time to finish making everything as unambiguous as possible. After working group last call, we'll make improvements that are identified and hopefully be ready to request publication, but that's up to the chairs and what happens during last call, obviously. That is the end of my presentation on this draft. I see Hannes Strofinnig at the microphone.
Thank you, Mike. A question, or it's sort of like your feedback. So when you imagine you have a CWT, and previously in the JWT we provided, for example, for scopes and also for audiences, sort of like, as you said, with scopes it was just a string, presumably something that is even meaningful for a human to understand. And for the audiences, ideally you want to have a URI just pointing to the server so that the matching is a little easier to do. But it could also be a string if it's, particularly if it's it affects multiple different parties. So in a CWD, you ideally want to have spent as little space as possible, but still we today have a sort of a string encoding. How would you go about sort of reducing the overhead? Because that's like in other places we shave off like bits or a few bytes, and now we have these strings in there. So how do you see that? Do you think it's just
fair question? Let me address your questions about audience and scope separately. Audience might be a URI, but it is very intentionally a string, and the language in JOT, which I and some in the room wrote, mirrors the SAML language, which talks about a value that the recipient identifies itself with. That doesn't mean it's a URL of the thing. It could be a logical value, like an organization name. It really is context dependent what a valid audience is. And so if you are in a particular profile, I'm sure the profiles will say, this is the format of an audience. But at the sort of token level, we wanted to leave appropriate audience values up to the profiles. Let me address his scope comment and then take the next speaker. Scopes are not something defined in JOTs. And one of the simplifying assumptions going into this work that I think has held up well over time is we were going to exactly parallel the claims that are in a JOT in a CBOR web token, establish the parallel registries. So for instance, the next draft, the proof of possession draft, will use that registry. And in fact, the ACE OAuth draft will use that registry, for instance, to define a scope claim in the context of CBOR web tokens. And so once we get this done, the mechanism through IANA will be in place for scopes and any other application-specific claims to be created and registered. Now, what scope values should be? Gosh, what are they in OAuth, right? It's really pretty application dependent. And this is another place where we think that ACE profiles and IoT profiles, if they have scopes, will probably use short ones, but that's up to those profiles to define what scopes are even meaningful. Does that make sense, Hannes?
What I was also trying to get to is, or I was wondering whether it would be useful to define maybe an additional data type for those two things where today we have strings, and maybe this would be just, would also allow maybe integers or even binary values, because those tend to be more efficiently encoded. With the downside of basically making it more difficult to reuse existing backend infrastructure, because there the user interface obviously wouldn't allow you to enter, let's say, a hex value to just represent a binary value. So there's a little bit of an issue there. But I was just curious on whether other people had sort of bumped into the same issue.
Yeah, Carsten, indeed. You said the audience is a string that somebody identifies with, and IoT devices often identify with a hash of their public key.
With what?
With a hash of their public key. And it would be nice to be able to convey this hash in binary. So I'm not sure what the right answer here is. So one answer might be we open up the audience claim. Another answer might be we keep a JOT-compatible audience claim in there, but actually go forward and define other kinds of audience claims that are useful in specific applications, for instance, where we have hashes of public keys as identifiers.
Well, and this is just me as an individual talking off the top of my head, but the CBOR data format is type sup descriptive, as you well know. And so if the working group thinks it is the right thing to do, we could allow either strings or binary, and it would be detectable by implementations. Depending upon the profile, it could make some implementations bigger, it could make some of the data types smaller. And I think that's an appropriate thing to discuss during the present working group last call. I will say, there have been other places where we took Jose and Jot data structures and did change the type of them. Jim changed the key ID, and Jim in the working group changed the key ID from being a string to binary in Jose. That was probably a good call. And so, I'm not religious about everything that was a string in JSON land has to be a string in CBOR land. There's use cases that it may make sense for stuff to be binary.
Yeah, I think we should definitely continue this conversation on the list and see what sort of things come up there. And I think we have Ludwig in the remote queue.
Ludwig, you're on?
Yes. Can you hear me now?
We hear you,
Yes.
Ludwig.
Very good. While we're discussing claims, I have a question. If a claim is defined and the ACE framework uses it as a parameter, for example, in a token request, do we need to redefine it, or can we just point to the claim definition? Since a claim, as far as I understood it, is something that is in a CWT or in a JOT, but here we're using it in the same meaning and same semantics and same syntax, but in a, for example, token request or token response or so.
Sure, that's a great question. I'll first give the party line answer, which I happen to believe is the right answer, which is the defined claims are those in the IANA registry for CWT claims. And there's the registry to add stuff. This draft adds some initial claims. The POP draft adds some more. The ACE OAuth draft adds some more. And to the extent that you want, and this was one of my comments in my individual review of the ACE OAuth draft, that to the extent that you want to use the same numeric space or the same numeric values for parameter numbers and claim numbers, I would suggest actually registering those as claims using an appropriate part of the number space. And as I said in my review, stuff that's application specific should not be using the 1 byte values. They should be higher up in the space, but now I'm down in the weeds. Is that helpful, or do you want to give me more feedback or give us more feedback?
No, that's fine. That's fine. Thank you.
Thank you, Ludwig. Kirsten?
Yeah, let me just add to this binary thing. Indeed, CBOR is self-descriptive. It may still be hard to find out what kind of binary string you're actually looking at. I think we have a somewhat reasonable idea what a text string means as an audience. I'm not sure we have that for a binary string. So we could define that, or we could say, well, there are going to be different binary strings, and we use different claims to identify them. So that's the question I have.
And that's also possible. I think per Ben's comment, this is a good discussion for the list at this point.
Yeah, and so in the interest of time, I think we should go on to the next slide deck, which is still Mike.
All right, as those of you who followed the CBOR Web Token work know, one of the additional claims which parallels a JOT claim defined in RFC 7800 is a claim for representing proof of possession keys or references to them, and that's what this draft is. I wrote an individual draft, and that after a working group decision that started at IETF 99 and was confirmed on the list, we adopted that as a 00 working group draft. And since that, review feedback has come in from Ludwig, Jim, Samuel, and others. Primarily changing the examples to use CBOR diagnostic notation instead of the lazy JSON that I'd copied over from RFC 7800. And Samuel added a table helping people understand the overview better, and Jim made a bunch of detailed comments, a lot of them on exposition, some of them on semantics, which the authors got some of done before the publication cutoff, and we plan to work on those this week. This is an even shorter presentation than my last one. We decided that we could probably do this fast last IETF because it was just a recasting of something that's already in production use. We're changing a syntax. We're not inventing new semantics. What we need from you to keep this going fast is extensive reviews at this point. It's entirely possible. In fact, I would bet that there are still places where there's JSON remnant language left over or things written as if we were talking about JSON that we should instead be talking about CBOR. And so my request would be even hopefully that we get a few specific names in the minutes of people who are willing to read this actually very short draft.
Yes, I was just about to ask, are there any volunteers in the room who want to go forward and say that they're going to review this draft?
Hannes's hands are up.
I see, I see Karsten and...
Karsten, thank you.
Thank you.
Do you think there are zero technical issues outstanding? Is basically editorials?
Do I think there's technical issues?
Zero. Do you think there are zero technical issues at this point?
I think there are exposition issues in the text. I do not think that the semantics will change at all, or at least the intended semantics.
Okay, so I guess a potential work group last call is close. Okay. Mike, did you have anything else?
I did not want to put the working group last call question on the slides because that's your call, but when you think it's time, we do want this to keep going. And as I said to Jim, I don't think the contents are going to change. As one piece of background, some of you may not know, Ludwig and I independently wrote down nearly exactly the same thing. Me in an individual draft, him as part of a ACE OAuth draft. And that, to me as an engineer, is one of the confirmations that we probably have this pretty right.
All right. I think our next slide deck. So, Ludwig, do you want to introduce yourself into the presenter mode?
Yeah, I should be sending video and audio now. Great.
Yes, we can hear you and we see you, so go ahead.
Perfect. So this is about the draft IETF ACE OAuth ALF. And next slide, please. Version 08. So major changes from 07 to 08. We moved the discovery of the authorization server from the details profile to this draft, since we discussed in the last meeting that it felt generic enough to be in the framework instead of hidden in a profile. So thank you to the authors of the DTLS profile, except for myself. We removed the definition of the proof of possession, which is now in the draft you just heard the presentation about, so that we don't have it twice. Then there is a change that will probably be discussed. We made CBOR the mandatory data format. The reasoning behind that was if you have the bandwidth to use JSON, then you can probably use OAuth and JOT, and you don't need ACE. So that is like open for discussion, but I just wanted to make that change as to spice up the discussion. We made the claim and parameter abbreviations mandatory with the same reasoning, since you really don't want to have code that needs to parse both. It makes the code more complex and it makes the messages larger. So if you have the bandwidth to do that, then you probably can use OAuth right away. And also, we made it mandatory for the profiles to specify not only the security between the client and the resource server, but also between the client and the authorization server, and in case they support introspection, between the resource server and the authorization server. So that's the biggest changes. Then there is a bunch of editorial changes, thanks to the two very thorough reviews by Jim and Mike. And next slide, please.
I think Hannes thinks it might be too interesting.
Okay.
And is that the microphone?
Sorry.
Yeah, Ludwig, see me. Hi, Ludwig. Yeah, if specifically on this mandatory CBOR format, but also on, which was earlier in there, also the mandatory co-op format. I think it, and specifically with the last line, you mentioned that profiles now also need to indicate the client authorization server interaction. I'm curious on whether we should probably relax this a little bit. And here's my thinking. In some sense, we have a couple of profiles that talk about protocol mechanisms that go beyond the use of co-op. For example, we discussed on a mailing list MQTT, and who knows what other things that will come. And so mandating co-op seems like a little bit odd, even in cases where you think of a scenario that where I use a tablet or a smartphone, it does the regular OAuth dance, and then itself uses, let's say, co-op to talk to an IoT device. Even that setup wouldn't be possible with the current framework, and I feel it's a little bit over-restrictive for no good reason. Or if I have an MQTT profile where I want to use MQTT between the client and the resource server, I suddenly, according to this framework, I have to use CBOR between the client and the authorization server, which also doesn't seem to be right. So I think we should be a little bit more relaxed about our what's mandatory and what's not in a framework, and leave some of this also to the subsequent profiles. Okay, to answer a part of your comment, co-op is already optional. We made that change. I think that should have been a bullet point here. Well, I read on the plane over here. I read through the specification very carefully, and besides these what I call larger issues, I think it's also it didn't, maybe it was, the change wasn't made everywhere. So there's still, yeah. So I can obviously send a pull request, but I wanted to bring this up. I did add a very specific line of text saying co-op is just used as an example throughout the document, and you can use other protocols as specified by profiles. But there might have been a remnant somewhere that sounds like co-op was mandatory. Please point that out, or fix it yourself. You're a co-author. Go ahead. Yeah. Well, I would like to discuss it in the group first before I make changes. Like it's a working group document after all. The other thing is that I wanted to bring up, which is not on the slide, is this. I'm still the client token, and I've seen Mike's review. The client token still feels a little odd to me. It's just so different from OAuth, and so I still have a sort of a fuzzy feeling about it, because it has just received it's just not as well understood as many of the other parts. So there seems to be some imbalance. And specifically, one of the nice things about the other sort of classical OAuth models is that if you do an authentication, specifically if you involve the user, you can use any authentication mechanism that you like. But then if you switch to this client token, since you basically have to talk from the client to the authorization server via the RS in a one-shot message, you obviously can't use sort of any authentication mechanism. So essentially we are down to presumably some public key or symmetric key mechanism between those. So it is not just from a messaging point of view different, but also from an architectural point of view. So it's just something I'm not entirely sure, and I wonder whether we have enough experience to put it into the framework, or it should better go into a separate document and get some more security analysis first.
Can I ask to switch to the next slide to answer this?
We do have one more question at the mic.
Yeah,
Yes,
but the client, since the client token was mentioned, notice I had a bullet point about that.
Okay, so Göran Selander, I'm trying to get this mic up, or else then lift the whole thing.
It is a wireless microphone, so you could take it out of the stand, if that helps.
That's clever. Here we are. So I had a couple of comments on Hanet's comments here. Let's see which order. So if we take the last thing first, on the client token, that is a new feature in ACE which is not represented in OAuth 2.0. And it basically represents the difference in the architecture. So in ACE, there is a possibility to do mutual authorization. So it's both authorization from the point of view of what the client is allowed to access, and also what the client is supposed to do, basically what actions the client should take. And there are use cases which we've seen in, for example, in the enrollment setting, where both the client needs to be authorized to enroll, but the client needs also to know it's a joining device. Am I authorized to join this network? So in that setting, the client token makes sense, and it actually fits with the architecture. But it is a different thing. I still think it should remain in the framework, because the framework is sort of describing the entire picture which ACE is painting. So that was one of the comments. Another comment was regarding to CBOR mandatory, and I wonder, is there a difference there between sort of where you mandate CBOR? We are now looking at both. There are three nodes here. It's the client, the resource server, and the authorization server. And the lig, which is most important from constrained point of view, is between the client and the resource server. So that's where we need to make sure that the objects are really small and it's low complexity in the processing. So could it make sense to mandate CBOR on that link, whereas when the client is communicating with the resource server, with the authorization server, or the resource server talking to the authorization server, we don't need to be that strict in exactly what format to mandate.
Yeah, on the latter issue, so that makes sense to me, because also if you use, and that comes back to my earlier comment, to the HTTP comment, if you use OAuth, regular OAuth with HTTP, then you're not using CBOR there, obviously. So in that sense, it's not just about the co-op, but it's also about this this aspect. There's as you said, like CBOR falls into the question of how do you encode the parameters in a request, but also the CBOR web token. And there, I'm not sure we need to mandate the CBOR web token itself either, because there are some cases where obviously the client doesn't know about the token format. The resource server may not care about the token format either, because it may do an introspection and may actually not get a self-contained token. It may instead use a handle. So I think we need to be a little bit more careful in sort of mandating things in a framework and the implication it may cause to the overall architecture.
My question to Hannes is, why shouldn't the client know about it?
Did you say your name?
Oh, sorry, I'm Henk.
So the client doesn't know about the CBOR, the format of the token encoding, because that's the way how OAuth works. Is that cool?
Okay, so this is again about the framework level only, not about the whole profile level. But it includes
even in the profile level, the client doesn't understand the token format.
Yeah, maybe that is a problem.
No.
No? Okay. But I wanted to highlight that maybe that is a problem.
If I may comment myself, one drawback with making CBOR optional and allowing other formats is that it also increases the code complexity. Like you have to prepare code to receive both CBOR and JSON and whatever other formats we later come up with. And that increases the possibility of doing something wrong. So my motivation for introducing that was to keep the code simpler. You just have to be prepared to parse CBOR. But that's not the hill I'm going to die fighting on. So if the group agrees that we should make it optional, I'll undo that change.
So this is Mike Jones from Microsoft. I agree we want the code to be simpler, but I think it's very unlikely that any particular implementation would support multiple formats, at least in an IoT context. This, after all, is a framework document, not a protocol document. And particular profile documents will profile the framework and say which data formats to use, which protocols to use, what the format of an audience is, et cetera, et cetera, et cetera, turning it into an actual protocol specification.
Right.
And I don't think it's the place of the framework document to bake in those choices for the profiles. So one of the things I did say in my pretty extensive review was, yes, define new features if you think some profiles will need them, but make it clear that whether they're required is a profile decision, not something imposed by the framework. And that's a comment that sort of flows throughout most of the document.
Sure. I do want to make sure that Ludwig has time to get to the rest of his slides. So
Sure.
I don't know what Kirsten wants to say.
Yeah, just have a one sentence comment. Of course, a profile can change things that are in a framework. And if we follow that thinking to the end, we don't need a framework document. Let's just do the profile documents, and we're done.
Or actors. But this is Hannes. One line comment only, one sentence. I think it's not as dramatic as portrayed, because the complexity is different on different nodes. I think it's totally acceptable for the authorization server, if it supports a diverse set of use cases, to support a JSON-based encoding and the CBOR-based encoding. The client, from a token point of view, doesn't need to understand either. And then on the resource server side, it really depends whether you use token introspection or not, whether you are actually going to pass the token directly at all. So even there you have some degree of flexibility. So I think there we are really talking about the implementation complexity mostly for the authorization server, where it shouldn't be a problem to begin with.
All right, Ludwig, your next slide.
Yes. So I think we already had the discussion about the first bullet point. The client token, should it be in this draft or should we split it out? Basically, my arguments fall where it covers the use case for a client with intermittent connectivity, and we define that use case. So if we take it out of the draft, we will have a use case that is not covered. The drawback of having it in the draft, as the discussion, as it was pointed out in the discussion, is this makes the draft even less like OAuth, and it adds like a new element to the draft. So I guess that is something we should discuss on the list. There was one question by Mike in his very extensive review at the end, and that was the relationship to token binding work in OAuth. And since that work started after our draft, I'm not really familiar with it. The question is, can that be specified in a profile? And would someone be willing to write that drafts? I'll leave that open for discussion on the list as well, unless someone jumps to the mic and volunteers. Okay.
All right. So do you want to send a specific email to the list to ask that question?
I can do that, but not now. I'm going back to sleep after this presentation. It's 2 a.m.-ish. No, 3 a.m. for me. And the third bullet point, what parameters to return in an unauthorized request? That was a comment from Jim Schad in his extensive review. So Jim suggested that the resource server should return the audience and scope it expects for a unauthorized request. And obviously it should be in a format that is not readable for a unauthorized client, but only for the authorization server. But the client could take that and pass it on to the authorization server, and then the authorization server would exactly know what audience and what scope this client needs to get access. So I don't know if we want to discuss this now or if we're running low on time. I guess since we had an extensive discussion before, we might be running low on time. So it's probably a good idea to also take that discussion on the list. But that is like the big issues I saw to discuss. Next slide, please. So next steps, except for, of course, the 3 discussion points I mentioned, is we need to resolve some editorial issues. There were a number of IANA-related comments that Mike pointed out to us that we didn't manage to fix before the cutoff, and that we will do. And thanks for that review. I specifically asked for a review of the IANA sections, and Mike did a great job in pointing out all the flaws we had managed to build in there. Otherwise, we have code that is ready for interops, at least for the current working group drafts version. So if anyone else has some code, we would be willing to organize an interop. And that was it for my presentation.
Hi, Ludwig. Francesca Palombini. I just have a feature request from for the ACE document, which is to be able, I don't know if the last update has anything like that, but to be able to send several profiles from the AS to the client at the same time.
Client, yeah.
If the working group thinks it's.
What would that do? Tell a client that the resource server supports several different profiles?
Well, that's one, and I think this relates to a comment that Hannes had last meeting on the multicast document. He was talking about interoperability and how to choose your profile, and I think that's a comment for the ACE framework rather than specific profile. And the other thing is, well, I would have a use of it in the PubSub profile that I'm not going to talk about it this meeting, but that uses 2 profiles for a publisher. So if that could be done in one exchange, that would be good.
So basically, the authorization server would indicate a list of profiles to the client,
that the client can use,
that the resource server supports.
Yes, because the client, if I understand correctly, the client has no way of saying, specify which profile it supports when it does its request, right?
Yeah, what we did was the client has to be registered at the authorization server anyway, so we assume the authorization server knows which profiles the client supports.
Okay. Where is this specified in the ACE? Because I didn't see this.
I think there is some text saying that we expect the client and the resource servers to be registered at the authorization server, and there is an appendix specifying what knowledge we assume the authorization server has of both the client and the resource server.
Okay, thanks.
But I might need to go through the text and make this clearer in case it isn't. So I'll take that as a future work.
Okay, I think, Francesca, you are up next, unless, Ludwig, you had any other notes.
Nope, I'm done.
Hello. So this is status update for the OSCORE profile for ACE and some next steps. So the OSCOAP, or now it's called OSCORE profile, was presented at IETF 97, and we are version 06, which is updated according to the latest OSCORE updates, which are minor. We have moved the use of ad hoc to an appendix, so now it's not in the main body of the document. And we have just added appendix that is the same in the ACE framework, saying which parameters the profile specifies. And there are 2 implementations in progress. Open issues and next steps. So thank you, Ben. Now we have confirmed that it's adopted, so we're going to submit this in the ACE document. And one question I had was, is an OSCORE profile using HTTP rather than co-op something that the working group would be interested in now that OSCORE supports HTTP too? And yeah, we would need more reviews.
So I'll ask the usual question. Is there anyone in the room who would like to step forward and say they're going to do the review? Is that Paul?
Dave?
Dave?
Göran?
That's correct, not Paul.
So I don't hear anybody saying that OSCORE and HTTP is something. Okay.
Okay, Göran Selander, can you hear me? So I'm going to talk about the DTLS profile, which is also an adopted profile. And these slides were prepared by Olav Bergman, and he's unfortunately not here, so I will walk through the slides. Just a reminder, for those who are new, what is the profile? So the profile is essentially something which specifies how you transport authorization information to a resource server, and keys as well. And these keys are used to authenticate, and the information is used to authorize access to resources on this resource server. And in this case, the authentication is based on DTLS. And the changes since last time is the working group document is now available on the GitHub, ACE GitHub, and a number of issues has been closed. So there were issues discussed during the face-to-face meeting, some issues raised by Hannes in the review, and some small editorial changes. And we're also going to discuss at this meeting some open issues which we have proposed solutions for, which are already implemented in the GitHub. The implementation status is that there exist 2 implementations which are ready, as far as I know, to this version of the document. It's the 6th implementation, and Jim also has 1 implementation. And there is yet another implementation planned by University of Bremen. So a couple of issues to discuss. Issue number 10. So this deals with the fact that this profile specifies a shortcut or a different way of transporting the authorization information to the resource server using PSK identity in DTLS. And the issue here was, how does the client know which method it should use when it communicates with the resource server? Should it use the post to the authorization information, that's item A here, or should it use the PSK identity? So how does the client know what is supported in the resource server? And the answer to A is very simple, because A is mandatory. So that's something that the client always could use. And so the question remains, how does the client know whether the PSK identity version of transporting authorization information is supported? The alternatives are essentially that either some information is provided from the authorization server to the client, which is telling the client that yes, this resource server is supporting this feature, or the client could just try. It tries to put the access token in the PSK identity in the client hello, and if it works, then it works. And if it doesn't, well, then it has to fall back to the authorization information passed in the with this case A here. Client, sorry, Carsten.
Quick question. So A is mandatory, which it has to be able to reauthorize. But I think it's important to note that the client may not be authorized to do that before it has gone through B once.
Okay, so that's a good comment. Since the only mandatory method to transport authorization information is using A, in general, that would always be possible in general, but you may have a policy on a particular deployment which says that you must first use the PSK identity because that's part of the authentication procedure. Okay, so that's actually not this issue. It's actually another issue, but adds a constraint to how to resolve this issue. So the proposal for a solution of this particular issue, number 10, is to allow the trial and error. And that strategy also works for the security policy issue that Carsten mentioned here, because you could always try to make a post to the authorization info and get back not authorized. So that's actually, it's at least as far as I can understand right now, a way to resolve also that problem.
This is Hannes. I don't think you would get them back in unauthorized if you try the BSK identity shortcut. The DLS handshake would fail.
No, the A, in version A.
Okay. So you first tried A, but that always works because it's mandatory. So no, the other way around.
Just because it's mandatory to implement doesn't mean that the security policy allows this client to use it.
Okay. But then, and the other one is it? Okay, so in essence, you have to implement both.
No, you don't. So you can still implement only. I mean, either. So this is a deployment-specific thing. So either this deployment supports unauthorized access using post-authorization info. In that case, you only need to implement that part. Or this is another deployment which says that you must authenticate before you do post-authorization info. And in that case, you could implement only, in that case, you can implement both the BSK identity and the authorization.
Yeah, so with the BSK identity shortcut, you actually then, if that works, you don't need to have A.
You do.
Why? Because that's the whole idea of the shortcut.
No, there is also
A, but of course, if you reauthorize, it's a shortcut to actually do this to auth info and not via a new DTLS connection.
Yeah.
So just reiterating what Karsten said, that for the reauthorization, you don't want to re-authenticate, and then it's easier to use the post-authorization info.
Right.
In case both are implemented. So the bottom line, this sounds very complicated, but the bottom line is that we actually support a range of deployments.
Yeah, so first of all, the BSK identity shortcut is only for, as the name says, for the BSK, not for the raw public key. But
yes, but that's the case we're talking about now.
But the interesting thing is, if you then use the shortcut of the shortcut essentially to post the new token, the Bob token into the authorization info, you are in essence not really, you are skipping the re-authentication, but would you still prove possession of the key? Actually, you won't. Is that a problem?
That's an interesting question.
So I don't know, because that was the whole point all along, that we would then.
So the setting, I think I can answer that question, Hannes. So the setting where you re-authenticate based on PSK, that token doesn't carry a key. It only contains the key identifier.
Either that or it carries the same key.
Or it could contain the same key, but it's not necessary. So there is no need to do any additional proof of possession. Okay, we should continue this discussion, but I think, as far as I understand now, the proposed solution addresses also Karsten's issue here, or Karsten's point. Okay, next. One question on the mailing list was from Hannes, I think, on whether the pre-shared key and the raw public key are two different profiles. So the ACE framework supports both PSK and RPK. And if we specify a profile with CoAP DTLS, how do we know whether that's a PSK or an RPK-based authentication? And the proposal is that we don't, this is an open question. My personal proposal would be that we don't make any additional specification in terms of RPK and PSK, since we can do without that. That's actually available in the information coming back from the AS to the clients. But this is an open question. Any opinions about that?
Yeah, Carsten, I was wondering, do we have a data item somewhere that says which profile this is?
That should be an IANA
yeah, but
registry.
Where is that? With a PSK profile, you just build the connection and you're done. I mean, you never say, "Hi, I'm using the PSK profile." You just do it.
Right.
So if we did have a data item that says which profile it is, then I would strongly argue to say these are two different profiles described in one document, And we have two data values for that, but I don't even know which data value we would have.
But the information, this information is not going from the client to the resource server. This information is going from the authorization server to the client. But you're asking the question, should it also go from the client to the resource server?
No,
is that your question?
I'm wondering, do we even have a data item that carries that information?
Yes, there is.
Yes, there is.
It's in the framework.
Okay.
So the framework specifies the information going from the authorization to the client, and there is a profile claim, which essentially contains
so then there
either.
Should be two different values for that.
Yeah, yeah.
I've, on the profiles, I've been wondering about one aspect, namely, in some sense, like the BSK versus raw public key seems to be two different things, but in terms of like TLS, it's basically you negotiate these aspects. Of course, the server could dictate. So if you have, of course, you could have potentially the mismatch. So the authorization server would provide some guidance on what does, or hints, what does the other party, the resource server actually implement. But on the other hand, it's probably less sort of severe as it is because of the negotiation mechanism, as it is in, let's say, a difference between this DTLS authorized versus, let's say, MQTT, because then you would obviously have a deeper problem because you wouldn't even get started, or the OSCORP one. So that would be different. So I'm curious on whether there's actually the profiles, whether it's a possibility to actually describe not just in, I see this as a la carte versus sort of the cipher suite approach in some sense. So here you have the DTLS or TLS, and then there's the transport, and then there's also the credential question. Or is it better to munch this together, and thereby you have indicate, as Francesca previously said, you indicate a list of different cipher suites or profiles, but then you have to use one of those. So did you run into that when you worked on the implementation?
Did you want to say anything here, Francesca? No? Okay. So I think that's, I mean, you have a very good point here. So you could continue this path and go down the road for, oh, Jim had a comment. Okay. So go ahead.
Just a comment. If you do without two different tags for these two different cases, then if someone implementing this wrong, like at the AS, then the client would have a problem deciding which one to use. So it may be good to. Anyway.
But okay, just to address Francesca's comment, but the other information contained in the response, token response from the authorization server, either contains a symmetric key or a public key. So you wouldn't hesitate about what.
Jim, from NoHab, just from implementing this, I mean, basically, whether you're doing PSK or RPK is pretty easy to tell because the AS identifies to the client, this is the key you should use. And distinguishing between those two is pretty easy. Yeah. And in theory, right now, the AS is supposed to be configured with the capabilities in terms of whether the client and the and the resource server can do which of these they can do, and in the case they can do raw public keys, what their raw public key is, so we can tell everybody. And the same thing would be true with which profiles are supported.
So that's what I was getting to. Maybe I didn't express myself super clear, but that's why maybe even though I raised this issue, whether this is one or multiple profiles, but maybe the answer here is this is actually the profile co-op DTLS, because whether it's an RPK or a BSK is actually information you get anyway from other sites. That was what I was trying to articulate. So maybe the answer to my original question is it is actually one profile, but it's not the one that is listed up, or it's essentially the shorter version of it. Yeah, so basically I've answered my own question. Yeah, okay. Great.
Okay, very good. Now we're solving things here. This is the third issue, looking at the time or the chairs, and this is the final issue, and then there is some wrap up. Just so issue 14 is dealing with a related issue as was discussed, number 10, about the PSK identity. And the question here is that since there are multiple options to use the PSK identity, what is the complexity in the implementation as a result of this? So for example, the PSK identity is now, with the DTLS profile, it's overloaded, so you could also contain an access token, as well as an ordinary key identifier. So how would the resource server, how would this be implemented? Or do you need to indicate whether a PSK identity contains an access token or a key identifier? And the proposal, which is sort of committed on the GitHub, you could look at it, is that we actually allow the resource server to again try the different options. So when you receive PSK identity, you first verify whether this actually identifies a key which you could use for DTLS, and if not, then you try to verify the byte string as if it were an access token. So that's the proposal, to handle the complexity also in that case, that both cases are supported, and you only need to have a sequence of processing steps identifying which are the cases in a particular request. Any comments on that? Okay, good. So the next steps, there are a few issues remaining on the GitHub. These are mainly resulting from the review of Jim, and we are happy to see more reviews of this profile. And also, if people are interested in implementing, we'd like to make an interop test. One issue which we may discuss here is the mandatory curve for implementation. And the proposal from the authors is to use the Edwards curve, the ED 25519. So this is sort of marking a progression from ECDSA to EDDSA, which we think is the right step to take here. Another thing which is also already implemented as a proposal is to use binary data in PSK identity. So previously, the text required base64 encoding, but that's not necessary. Finally, we'd like to make some more examples. That's also what's also one of the issues. So, any other comments on this draft? So the next step is basically progressing the issues and testing the implementations against each other.
Yeah, I'll ask the usual question. Anyone want to raise their hand and say they're going to review the document? Francesca, yeah, Hannes is stretching again. Does anyone want to raise their hand and say that they're interested in implementing it? Maybe not. Okay.
Okay, I had a final comment then from my side, and that's an announcement from my employer with regards to the note well that Ericsson may have IPR on this draft, and there is an IPR declaration in progress to be announced this week. So you could, as usual, you could follow the links from the draft to find out. Okay.
Okay, thank you. Marco, you're up.
Hi, Marco Tiloka, RI6. Quick update on this other profile of ACE. Of course, the goal is to enable IPsec-based communication between client and server, resource server in ACE, taking advantage again of the independence of IPsec for the sake of key management and establishment. So you can go in principle for pre-established pairs of security associations or IQVT as particular example of establishment in symmetric or asymmetric mode. And dependencies are, of course, limited only to the ACE framework and in particular IPsec and IQVT2. This is just an example with reference to IQVT2, and I said the profile supports both direct provisioning of security associations prepared and issued by the authorization server, or you can go for an actual key establishment protocol, especially IKV2, of course, both in symmetric or asymmetric key-based mode. A few updates. Well, on the draft itself, only minor editorial updates compared to the previous version. So we try to clarify also a few details aligned with other profiles and the framework, especially also for the optional use of IPsec for the sake of protecting communication with the authorization server. But you can in principle go also for other means. And any other relation for alternative key establishment modes other than IKV2 is purely informative now and totally move to the appendices. The biggest news is actually that, as I mentioned in Prague, we were working on an implementation that is now completed for Contiki and available on the public GitHub, supporting both the direct provisioning of security associations and IKV2, both symmetric and asymmetric key mode. And that was tested on Zolercia Firefly modes. We are currently running advanced performance evaluation to support scientific publication. Of course, comments, reviews of this are welcome. That's it.
All right, I'll ask usual question. Anyone want to raise their hand and say they're going to review?
Carsten, moment, a question. What is the level of symmetry that can be achieved here with the DTLS profile? So, for instance, do you have something like PSK identity on the IKE level too?
It's quite high, of course. It's quite a lot. It's quite high. It's quite a high level of symmetry.
So you do have a way to tunnel an access token in the security association establishment.
I would say the security association and the access token.
Okay.
Dan Harkins, it looks like in here you can send an access token request with an asymmetric key in it, but from the looks of it, you don't have a way of doing proof of possession of the private key when you make that request. And I think what happens then is you can open up the subsequent IKE exchange to an unknown key share attack. So I think you should either provide some way of doing proof of possession, sort of like what EST does, where it signs the TLS unique from the TLS session, that, or you should put something in the security considerations, because right now you just say, we inherit all the security from IKE, and if you're violating one of the assumptions of IKE, then you can't really make that claim anymore.
Good point, thanks.
So we should go to the next slide deck, which is still Marco.
Hi, Marco Tioc again. So a few updates also on this other work on joining OSCORE multicast groups in ACE. So here the goal is to support joining of multicast groups where group members communicate through group co-op using OSCORE to protect communications in the group. And the point is joining the group by using the ACE framework and specifically its profiles. And the approach as such is oblivious to the specific profile you decide to use, and still it's flexible to arrange groups the way you want. So the actual goals of this approach are authorizing a joining node to get into the group through the responsible group manager, and especially establishing a secure channel between the joining node and the group manager to proceed with the joining process, and then initializing the joining node, especially with key material to participate in the group OSCORE communication. Two things are not covered in this document that's out of scope at the moment. One is further authorization of specific resource access of resources hosted at group members. That's just up again to the ACE framework and possibly profiles you decide to use. And second, the actual secure communication in the group based on multicast OSCORE that is instead described in detail in the specific document in the core working group. Simple and plain, think about the client of ACE as the joining node interested to be a new member of the group. the resource server as the group manager responsible for the group. Of course, can be responsible for multiple groups. And the authorization server that here has just to authorize the access of the joining node to a resource on the group manager to start the key provisioning process and then proceed having the joining node as any member of the group. And then for details such as secure communication between the involved entities and especially the client and resource server, I mean the group manager, you can in principle use any feasible ACE profile available. The joining process then in particular, it's a request response exchange at least between the joining node and the group manager that is then responsible for providing key material especially. The details about the actual message exchange and key material provisioning are now moved entirely in the main multicast OSCORE document. Compared to the previous version, we had a number of editorial changes, and especially we clarified something about the provisioning and handling of public keys of group members. Now we especially recommend that the group manager is configured to be repository of public keys of group members, that they have to provide them then upon their own join. And then also to address some comments we got in Prague to avoid possible scalability issues, we consider providing the public keys of the group members already in the group to a joining node only in case of explicit request from that joining node upon its join. These are the updates. There are a number of points still open under discussion that I wanted to raise up to you again. One is details about the exact message exchange, especially between joining node and the group manager. Something was mentioned in the previous version of this document. Now this is very high level in this draft, and details were moved as an appendix of the main multicast OSCORE document in core. So describing the message exchange with the group manager and how to handle and provision public keys especially. So the point is, do we want to have any of this detailed information here in this document, and what is the right level of detail for that in case? The second one, as I mentioned in the previous slide, it is right now out of scope to entrust the authorization server for anything but authorizing an access to the group manager for starting the join process. But in principle, the same authorization server can, of course, be used also to issue authorization to access resources at group members. So should we consider this point in scope for this draft? And in case, how should the two authorizations be combined in a single step? Third and important one, there were spotted similarities between the use of the ACE framework in this document and in the PubSub profile, other than previous thoughts on further generalizing the PubSub profile for group communication. And then in their own way, on the ACE framework, both drafts address key provisioning, so possibly parts of them can be merged. And especially, there's need to avoid the definition of multiple sets of messages covering this very same goal. So about this, what do you think the best way to proceed is, also with respect to the two documents?
Your answer down there. So your open points here, 2 and 3, I suppose they are potentially related. So because in the PubSub profile, you actually get directly from the authorization server an access token. So that's essentially kind of a similar question. And the first open point was more, is that more about the format or where things, is it about the format or is it about where things are specified?
Where are specified, mostly.
Okay, so it's whether things goes into the multicast OSCORE draft or whether it goes into the joining draft.
It's more good editorial choices.
Thank you.
Other than that, as next steps, of course, we are going to keep this document aligned with the ACE framework and its profiles and other details that can be added in the main multicast OSCORE document in core. And of course, further comments and reviews on this are welcome, and we are going to address the open points I've just mentioned. Then on top of this, this draft got like high priority label after the latest ACE interim meeting. So we wonder what is needed to proceed towards adoption later on.
The first thing that needs to be done is the two of us need to have a discussion about what amount of work we currently have in the group and whether we think this is reasonable work to proceed as a group item. And then we would issue a call if we think if that passes. So it will be a little while.
Thanks.
And I guess I also think we might call out specifically the question that was raised about, this document versus the PubSub document, and what should the relationship be? Does anyone want to come to the mic and make a comment about that now, or should we take it to the list?
Cosmo, I just wanted to repeat what I said, that I think it would be good to consolidate the group communication aspects into one profile.
Okay, and does anyone want to raise their hand and say they're going to review this? Karsten, who is in the back? Elliot. And, I got a couple more. Goran.
Peter.
Peter. Great. Thanks, Marco. And Peter is up next.
Good afternoon. Glad to be here again. Glad to be here again. Good. This is the first. Let me see. It's beautiful. So this draft has been presented already sometimes here. So. Okay, won't work. So it proposes to have used co-op and DTLS to support EST. The application areas are secure bootstrapping devices and also distribution of identity and keying material. I must make an understatement now. This is understated in the current version of the draft, that there are these two aspects of the EST over co-op. The two application areas where the original motivation comes from is to use this in Brisky with the 6-dish. So we know the pledge and the joint proxy and the EST, which has been done in Anima, and we want to do the same thing for small devices. On the other hand, there is a clear wish also to use EST in standalone and to have the point with the registration authority talking to each other and have that as a different aspect. I would just wanted to say some of the issues which I know about. So first of all is that the motivation of the draft, which is just current done about Brisky, should be extended, and that we also should talk about that we have the standalone version that should be emphasized more. There is a proposal by Hannes to have a second draft and that we could split. I think it might be an impossible solution. We should discuss that in more detail. There is a section about proxying in the EST draft. On the one hand, it is rather terse. It tells you about proxying between the co-op world and the HTTP world. You might also say maybe we don't want it in this context. So that is one of the things which is not quite clear here. In this document, there are of course many extensions to the EST which have to do with the Brisky, which is about getting vouchers and to support the transporter voucher. The server-side key generation has not been put forward. On the other hand, there are quite a lot of decisions taken here in the EST of co-op over co-op draft to remove functions which are supported by EST, because we were thinking solely about the Brisky applications. So probably if you want to have a standalone version, all functions of the EST should be supported. One of the points which were made in the former meeting that actually this draft is more a combination of existing drafts, so that there is very little information, additional information for standardization. I don't know what the working group thinks about that. Most people, as far as I know, who are interested, thinks that it is good to have all the details for the implementation as described currently in the draft. Another one of the current issues I know about is that we talk about the content formats use binary encoding and no others. I have also heard comments that maybe we should support a more content formats like that. Questions, remarks? Please. Oh, great silence. Good.
Hi, this is Henk, and this is a very high-level remark, but I really like laying out blueprints and architectures that show how to compose the existing building blocks. So I think this draft has merit and is useful. So it is although it is re-explaining existing things, it is very important to show how to compose them.
Okay, it confirms my opinion. Thank you.
Peter, this is Elliot. I also like the draft. Having had some discussions with you and Hannes, I also like the idea of making sure that things are and I agree with Hank's point that things should be properly composed. I look forward to working with both of you, and I'm happy to review and work with you on the draft.
Okay, very good, thanks. Any other similar supporting remarks? So, other things to do, a part of having this discussion with Hannes about how the draft should, the structure of the draft should evolve, etc. We had to fill in operational parameter values because for the moment we only cite them, but we don't give any idea about what value should be used. The motivation section should be changed because we want to have supported to different application area. The server-side key generation should be added and probably more things if you want to have this in standalone. I'm very happy if we could have this document in ACE, and I'm really looking forward to all the technical reviews we had so that we have a high-quality document that can be used. And there are, of course, others. Yes, Hannes.
I was wondering about the server-side key generation because I thought that one of the prime values of ESD was actually that it was on a client side, and having the server generating keys obviously creates a bigger security vulnerability, because now you have, even for like a public key crypto system, you now have essentially the two parties knowing the private key, right? That I could imagine, like from an operational point of view, liability point of view, that would be not be ideal.
Okay, yeah, I understand that point, but there are people who think that that is a valid approach, especially about the server, which have a higher possibility of generating keys within okay, I forgot the word, larger set of keys which are reliable. So that was, so we use an already reliable channel. We want to renew the keys, and we can use the server key generation from the server side, as the client may not be have resources enough to do that.
Who came up with that scenario?
Oh, very good one. I think it was one of my co-authors actually. Yeah.
Okay, so thank you, Elliot, for volunteering to review. Anyone else want to raise their hand and say they're going to review? Dan, is that you? Brian Weiss. Okay. The lighting is not very good. And we've got Max from Jabbers also going to review. So that's a fair amount of interest. Okay, thank you, Peter.
So I had this question here, but probably it's not the right question. I mean, I was hoping that actually this document would find a home here in ACE. That was the right question.
Yeah, I mean, the intention at this point is to do an adoption call probably in December.
Very good. Sounds great. And then we have solved all the issues with Hannes. Okay, fine. Bye. Please.
Okay, so now we're back to the chair slides for those following along.
Do you want to present this or do you want me to?
I guess I can do it. Okay, so we've had, I guess, for quite a long time, some extensive discussions about the group communication security topic, and there's been debate about using a symmetric key-based scheme or asymmetric key-based scheme, and so we really do want to try and get the sense of the working group as to where we are and what we want to do. So I guess one of the real key questions is just from a security and sort of security model and threat model perspective, what are the actual requirements? And if I'm pulling up the slides so I can actually see them too. So like, we know that with these things, we've got low costs and low latency constraints, and we want to translate that into actual security requirements so we can analyze different proposals and see what's going to work. Elliot, you want to jump in?
Yeah. As you're going through this, may I suggest a couple of things? First of all, there's never going to be a single set of requirements here. Right? The different devices, different deployment models. What you need in a nuclear power plant, it may well be different than, say, what you need for your enterprise lighting solution.
Right, and I think we're trying to focus on the lighting solution.
Well, what I was going to
right
suggest is we like to think horizontally in this organization, to cover if we can cover all the cases. And we have two choices, right? We could be very narrow in approach, as you're suggesting, Ben, or we can allow for the capabilities to support both. And I think that in itself is a question, right? So for instance, let's just be absolutely crystal clear, as an example. Are signatures required on every single message that emits from a device?
Right, I think we have that on the next slide.
Right, so the point being, right, that the answer is always going to be sometimes.
Right.
So that's what I mean by being horizontal.
Yeah, and I think so. We want to, yes, be aware that we should think about horizontal, but if we can be specific, is there even one use case that we want to consider that would require this work?
This is Hannes. So we know about one specific use case, and there we had people participating in a list explaining what their requirements are, and that was the indoor commercial lighting example. There were some other nebulous cases, but we don't have the community here. We don't understand exactly what they want. I don't understand what people want in nuclear power plants with this. I don't think we should design solutions for them, even though we like to work in a very generic case. But at least we have one use case, which is like volume-wise, industry-wise, large enough to justify some work. So I think we should focus something that where we have the community at hand, and they're asking us for a solution. We're working with some of the companies in the indoor lighting sector, and they've expressed those requirements. And so maybe we want to provide them a story. That's
right.
my take on it.
Right. And so if we can think about that particular use case and the requirements of that use case, and hopefully everyone has read the slide by now, does this seem like a reasonable translation of their requirements into security requirements? And that's a question for the entire room, not just for Hannes.
Göran Selander. So I haven't really read through. I'll read through it in a minute. But the people that I've been talking to in this industry, in terms of building automation and lighting, they express the need for a solution which can support both the case of low latency and less strict source authentication, like group type authentication, as well as source authentication. So both these requirements exist.
Both would require multicast?
Both require multicast.
And just Could you say a little bit more about the use case in particular, or did I miss that already?
Right. So it is basically a building automation scenario, and you need to activate multiple actuators with one request,
Okay,
but you still want source authentication for that actuation.
Right. So, actuators, if you can start thinking about doors or things that actually have physical security requirements as opposed to lighting.
Yeah, I mean, there are a number of settings in building automation.
Right.
Yeah.
Peter van der Stok, there is one requirement I'm missing there, which is the low latency. I think it's one of these. Where is it?
How do low cost, low latency? Okay.
Excuse me.
It's a requirement, but not a security requirement.
This is Dave Robin. Yes, I was going to point out that in building automation systems versus security systems, for example, latency affects the security requirements, meaning for lighting, humans want the lights to all come on at once. Therefore, we need to make some compromises in security. However, the command from a fire system to open all access doors it needs to be highly secured, but does not necessarily have to be low latency. So you see the trade-off is latency versus security. And I just want to throw that out there. And so the nuclear power plant is not going to shut down all the pumps immediately, because a human isn't going to say, hey, these pumps didn't all shut down at once. It's going to do very secure unicast communication to each one. So group communications that can be what replicast, we call it, which is an individual thing. I have this list of group members I need to send them to, but they're not multicast. They're one-to-one. They're secured in one-on-one. That's a list of people to receive the message. And there's no latency requirement there other than do it as fast as you can. But for the case where the latency is absolutely critical, like lighting, we have to trade that off with a little less security.
Yeah, and I think specifically, this is Hannes, the case where we didn't have the latency issue in the discussions, the unicast communication was perfectly fine. I don't think we had a problem with any of the unicast communication or any of the public key crypto. I think the contentious issue was about symmetric group communication security. That was the contentious issue. The other things were no-brainer.
Mike St. John's. One of the things that's happened in this thing, we've gone over and over again on the low latency thing, and I was thinking about back when I was dealing with voice over IP, and the people saying ringing must start immediately. When you when you press the button, it must start ringing within a small amount of time. Well, guess what? The systems don't work that way. So what ended up happening is your end starts ringing and pretending it's actually happening. So there are other ways of solving the low latency problem rather than this multicast group thing, especially when you're talking about, well, how many lights are you turning on with the flip of one switch? Again, the message may be longer, but there may actually be an authentication token for each one of the lights that you're sending, and it's getting multicast out, but you only care about your piece of it. So I understand why we keep going in this space, but I'm afraid unless you limit this protocol really specifically to these low latency, low security things and figure out how to do it in the protocol, it's going to end up with a field of use violation and something else. And that's really why I've been complaining about this since the beginning.
So among Mike, come back, please. I'm going to ask you a very specific question.
Of course.
Based upon what you have heard them say, do you believe what is up there represents what their security problem is?
All but the third to the last bullet.
Okay.
So among the solutions, so that's a new solution.
So, and just to interject, the third to last bullet is that multicast is needed for efficiency.
Yeah. so among the solutions that we had entertained on a mailing list, I think this one is new, just to change the user sort of behavior. But the other solutions that we have heard so far was, one is to use some new public key crypto systems like Derek proposed. The other one was to use different hardware, sort of different processors, hardware acceleration. And I think the multicast plus group symmetric key was the preference in terms of solution from the Lightning community, and we never managed to make a proposal on restricting the use of the protocol in such a way that Mike would be satisfactory. So he keeps pushing on us sort of restricting it and profiling it or whatever it in a way when he then goes off and says, it's actually not possible to do that because there's always the nuclear power plant that can use it and they will get it wrong. There are always some people who will misuse it and will do it. So it sounds like a little tricky. I think you are setting us up here.
Mike, you're still thinking?
I'm just trying to figure out whether or not to respond to the ad hominem, but I don't think I will. The key, would you sit down for a second and let me finish? The key thing here with respect to this protocol is that if you break into any device, you get privilege. You can raise your privilege. So if you break into a light, not a light switch, and get this key, you can raise your privilege. That is basically just an insecure protocol. And again, unless we limit it to this really specific, really, I don't care about security, but we're going to pretend we have security field, then we have to be careful about this working out into the wild. We're reusing DNS for things that it was never designed to do. I expect something like that to happen here.
But you would agree that that statement is covered by the third bullet point.
I'm saying that I think I can come up with solutions that do things that don't involve privilege raising if I don't deal with the multicast single key thing in that thing. So and that's the thing I'm telling you about. But again, the limitations are then how many can you put in for your things. So there's a whole bunch of trade-offs here. I'm not comfortable with the trade-offs they've made for this as a general protocol.
All right, 2 points. The first is that I should just point out that this work has actually been performed, right, in other standards bodies at this point. Both, I think it's KNX and Zigbee, both have now group-based mechanisms that do multicast, but do not, in fact, deal with a key management issue, which, if you ask me, is the hard part. So the point is that you know, the question is, can we improve on the work that they do? Can we actually raise the bar on security and help and actually provide value into the industry? And I think the answer to that is clearly yes, because we've had at least several proposals that do just that. The second point I wanted to make is that I think we have a bit of an application transport mix-up here, which is I think if we can establish the authorization within the transport level, then at that point we might be able to allow for the applications to choose the right approach, you know, in terms of what they have, with appropriate warnings and, you know, caveats and yada yada yada. But, you know, part of that might be in the data, you know, object signing when it's necessary, and or, you know, as in the case of the fire control system. Part of it may be not having that, but if we can separate maybe the, you know, the transport from the application, we might be able to move forward on this a little easier.
This is honest. We have tried to phrase the language in the document to fulfill what Mike was asking for, but unfortunately we never got any sort of like input on what he would have really liked to see, that it actually fulfills his need. Like in terms of text, it was just we tried, no, tried, no, tried, no. That was not very helpful for us in order to progress. On Elliot's point, and a little bit related to Mike's point, this is not about no security. Group communication is not no security. Why it is related to ACE and actually in here is because the ACE framework with the authorization server, client talk to the authorization server, getting keys, and then using those keys is actually the key distribution mechanism. So it's not, we are not talking about manufacturer provided group keys in all the devices which are then used to issue commands. That's not what we are talking about here. We're talking about the client authenticating to the authorization server, which happens to be then acting as a key distribution server in sort of the Kerberos type of style. It also needs to ask for permissions to do so. It gets an access token and then together with the group key, like in the other things we have just heard half an hour ago with the other profiles, and then using those. That's what we are talking about here.
I don't think Elliot was trying to say that this did not provide security. I thought he was saying that
Mike said it.
Others in the
and Elliot talked about like we also have to improve on the key management, which is exactly what we are trying to do with the ACE framework.
So, Dave Taylor, I have a couple different comments on the slides here. So let me talk about first the one that people haven't talked about before, but it is related, and then I'll touch on, I think, what I hear from other people saying. The one that I haven't seen touched on, it has to do with the latency constraints. And this goes back to the comment about application layer, transport layer, or network layer, or whatever, which is if you care about latency, you also typically care about reliability. Not always, but in many cases, like I want to turn on the lights, or I want to turn the lights red, or whatever it is, that's something that wants reliability, right? I need to know that they actually got on, as opposed to I have to retransmit or whatever. So that's actually the impact on the transport layer, not the security protocol, right, but the transport layer, right? And so the question here is about what's the security requirements, okay? Because it actually touches on multiple layers here. And so this gets to, I think, Mike's point about multicast is needed for efficiency. That's a point that's about the network layer. And technically about the transport layer if you talk about the reliability mechanism as well, not the security layer. And so I would like the requirements, because this is concrete security requirements, not concrete network layer or transport layer requirements, is the context of the slide, that I think the notion of whether you're using multicast or not is not a security requirement. And so in that sense, I think I completely agree with Mike. At least I think that was one of his points anyway. He's hand waving, maybe not completely. All right, fine. He said he'll explain it. And then finally, the topic on the low security environment and the fourth bullet, which is the intent to operate in relatively homogeneous systems. I think the fourth bullet is probably better worded than the third bullet. I think the third bullet is not worded as a requirement. It's worded as a justification for a lack of requirement, right? The fourth bullet is actually closer because the constraint is really that you're saying, when you're talking about things like shared keys and elevation of privilege, like Mike was talking about, that one role can somehow get permission to do another role because there's only one shared key or whatever, is actually, if the requirement is to be efficient when you only have one role and everybody is considered equal, that is one type of security requirement, okay? As opposed to a requirement to support multiple roles, like asymmetric roles, like light switch versus light, and trying to separate minimal number. I think there's a big difference between one and more than one. And for the security requirements, it would be useful to either say, we need a solution that's efficient for exactly one role, where everybody's a peer and everybody's treated equally, that all authorized entities are treated equally, right? You're either authorized or not authorized. Or there's a requirement to support multiple types of roles. That's actually an interesting security requirement, because I hear the solution being one, and I hear other people are arguing for the requirement is actually, if you care about security, you want to allow for multiple roles. And I think that part was actually closer to Mike's main point. Okay. This is what is the actual security requirement we want to target? And maybe there's two different ones here, but two different solutions, and one of them we're going to do first, one of them is later, or whatever. And I think that's the end of my comments, and so I'll probably sit down unless Mike says something I want to talk about. So
hold on a second, I've got a question for you. So if we're looking at the lighting scenario, the fact that you would not necessarily say that from the solution point of view, we would need to distinguish between activators and luminaries. The fact that a luminary can activate the rest of the luminaries is not a problem if we are basically saying everything's the same.
Sorry, I'm not sure I understood your question. From the
A light could turn on the rest of the
ecosystems
lights.
that I'm familiar with that do lighting, and so like OCF is one example of them. But other people mention, Zigbee, Z-Wave, and so on. What's that? OCF does lighting, yes. Lighting, yes. Whether you call indoor commercial depends on what you're using. My point is that there is a need to do asymmetric, where the restrict the set of people that can issue commands. That set is different from the set of people that can receive commands, or I should say entities, not people.
Right. No. Okay. So yeah, I've never claimed this doesn't have any security, but the security is all in the confidentiality piece. And turns out that that's actually a useful model for multicast group communications, because what you're doing is protecting the transmissions or the data. And guess what? If you're one of the receivers who's supposed to be getting it, if you break into the receiver, you're not doing a privilege elevation because you're getting the data that you would have gotten anyways. So that's why some of this is okay. Like I said, the second bullet is like, well, okay, that's really what a group symmetric key multicast thing works for, or it works for everything in common, a single domain, anything, everybody can control everybody else. It doesn't work for this asymmetric stuff in any way that is, you get to the point where this is such a limited space that, like I said, I'm not sure why the lighting people just didn't write their own document and do an informational. So anyway, you've gotten all of what I'm saying many times. I'm sorry to keep saying it. I hate getting misrepresented, because what I have said in the documents is basically, you need to fix this as a general thing. I keep telling them, you're offering me a tomato, and what you really need is a banana or something along those lines. So.
Hannes, I just wanted to point out that lighting is not equal to lighting. So you have commercial lighting, indoor lighting. This is the stuff on the ceiling over there, 100 luminaires. You turn them on. You have things like a certain expectation. You push the button till the light goes on. A time limit of about 200 milliseconds. You also don't want to have cascading effects. So you turn on, if you do unicast, you see one light going on. It looks like an avalanche effect. You don't. Apparently, the lighting community doesn't want that. If you look at the home environment, you have 1, 2 lights going off. It doesn't matter. There's no cascading effect. The requirements are different. If you have street lighting, again, different requirements. So just because lighting appears in a name, it doesn't actually mean that it's the same requirements. There are certain organizations, the companies who work in that, they work in different organizations. I don't think they're in the OCF and Tridonic, Osram, Sumtobel. So.
This is Dave Robin. Dave Taylor just said something that is not on this slide that I think is very important, and it has to do with the reliability of the delivery. And that is a fundamental thing. Are we creating a reliable group delivery mechanism, or not in this group? Exactly. But that has a lot to do with the design of the messages you're sending. If it's not reliable, then my entire application space has to be designed to be idempotent. I have to say ramp to 20%, not ramp by 20%. It changes the kind of things you can say if I don't know about the underlying delivery. So yes, this is security, but the mechanism we're creating says nothing about reliability. And I don't know whether that's a profile or what do we do about that?
So Hannes, again, my understanding of the requirements is that it's a one-shot message, unreliable. You send it out to these luminaires, one doesn't go on because the message, it didn't receive it. Not a problem because there are 100 others next to it.
Okay, I'm going to move to the next slide, and we've had some good discussion about these security requirements as listed and some modifications to them. So we have some more questions to think about. And so the first one is, are we comfortable creating a document that targets this level of security? And maybe for this level of security, we can think about there's only one type of thing. Everybody has the same permissions. Just to have something concrete to talk about, and ask, are we comfortable doing some work at that level of security?
Yeah, I just like to reiterate what I said previously, that I think we should address a solution which incorporates both this type of security and a setting where you allow source authentication. So I think both these should be in scope.
Sure.
Should not focus on
we
a
can do
specific
work at this level of security and at stronger levels of security as well.
Sorry.
We can do work that meets this level of security and also stronger levels of security, potentially even in the same protocol.
Good.
Yeah, I mean, I believe that we basically already have agreed that we're going to try to work on something that does do the source authentication, all that, because I mean that's the group communication stuff. What we're looking at really in this case is, do we also want to work on something at the very low end where we don't have the same set of asymmetric capabilities?
So I'd suggest that the answer to that is yes, and for several different reasons. The one that comes to mind immediately, though, is that I think there are people who are looking for a solution within the context of their existing hardware framework, so they can at least get to some level of secure. And they've told me, for instance, that 128-bit ECDSA still requires sufficient latency that they end up with what they call the popcorn effect, and they miss their 200 millisecond window. And so my thinking, though, is that over time, that latencies will reduce based on what's available, but at the moment, things are almost going the opposite direction. And so having the symmetric versus asymmetric, having both of those choices available allows for progression into the asymmetric space when it's possible for them to do so. It may not be possible for a Z80 to meet that requirement, and there are Z80s out there doing this stuff.
Oh, excellent. Mike is coming up to the microphone, so I don't have to call him out to come up.
One of the questions I actually asked once upon a time, and I've been unable to actually get a straight answer from anybody, is whether any of the lighting systems are safety and health concerns. For example, I understand there are some types of lights that are manufactured for hospitals that have a UV mode to them. Okay, can you imagine this system being compromised and turning those things on because somebody was able to get the key out of one of the lights? I get nervous about things like that.
Yeah, no, there are definitely some lighting applications that have health and safety implications.
Okay, he has a different opinion on that.
Yeah, I was just going to say, so if I'm going to repeat what Dave just said, which is that doesn't invalidate the use case that we're discussing, but my opinion, I know Hannah, I think is going to differ here, but my opinion is, or my perception at least, is that yes, there are different environments that where lighting is more or less critical in terms of its security, and that it's important that the people who are in those environments use the appropriately secure solutions. Just like any other technology, if I'm going to go buy a little web server for the home, it might look a little different than what what Google uses or what the NSA uses, though I don't know how good the NSA security is these days, but anyway, it's just, I think there are different environments and we have to respond in that case.
Dave, there, just explaining my off-mic comment, I said, are there health issues with lighting? Yes, but it doesn't invalidate the use case, right? The yes is if you can rapidly turn things on and off, you can cause epileptic seizures. That's the example, right? There's other examples, but that's the most obvious one. That there are potential health impacts, but it does not invalidate the use case. I mean, you still want to do it, even though, because there's this low likelihood that somebody might have epilepsy and be triggered by something. I think it's still valuable to have a low security mode, meaning a one role mode. I think it is valuable to have a multiple role mode, and it's valuable for the working group to define authorization models and protocols to do both. And so are we comfortable? Yes, that doesn't mean that you don't need to also do another one for other use cases, but my opinion is yes, even though yes, there is a potential health issue.
Yeah, and since Mike did not jump up to the mic and complain about this, I'm going to implicitly take it is that you could accept doing work with this one single role, provided that it's called out explicitly what the drawbacks of it are.
Yeah, the single role is sort of a confidentiality role or a common domain role, which is somewhat not what's been going on with the lighting stuff. The low security, again, the problem is that in some ways the low security role that we've been talking about is equivalent to no security. I mean, they're really just sending a message off on the links means that you have to physically get into the link somewhere, or you have to break into the RF point-to-point stuff. So I guess I get worried because I don't understand if this protocol will be used brought in a broader set than the things that we've got. My guess is it will be, because it will be something that's blessed by the IETF and people will go, oh, cool, it's secure. We've had that happen before. This one, because we're now talking about cyber physical stuff, concerns me more than I would if this were just a simple data protocol.
This is Hannes. Mike, I don't understand why you are saying it has no security. Like no security, like maybe it's a question of definition, but like I don't see why a key management solution combined with a way to protect the message over a wireless link offers no security. Like what's then the difference to just sending plain text messages? Would that be -1 security or?
A 3-foot fence provides security against a grasshopper. Doesn't provide a lot of security against a guy walking over it. So again, the question is, does this provide a high enough fence to be worth protecting against a guy with a $1,000 laptop? Take that as my basis for what I think the minimal barrier to entry is here.
Quỳnh Đen. So when we think about security, to me, there are 3 cases. Either we say, oh, I don't need security for this, then you do what you want to do. Or you say, security is important here, and you have to provide the real secure solution. Like for example, B56 or at 2519, for example. Or you can say, okay, I want to apply for this special case, and then you have to do the analysis for the cost and the benefit. And in order to do that well, it's extremely hard because the cost and everything else keep changing. And you have to look at the attacker perspective, what would be the cost for him to do this, and would be the benefit for him to get from doing this, because everything is about, the cost and the benefits. And it's really hard for you to be sure that your analysis is correct because it keeps changing. And your attackers could be anyone. And so it would be very dangerous for us to go into that direction and to recommend and say this is okay for people to use, because I don't see the good way how to do that matrix for the risks and the benefits, the cost and the advantage we get from weak security solutions. So it would be really bad, and also our solution could be adopted in many places, and when people see it's fast enough and they just go do it, they don't think too much about it. But in order for IETF as a community to give a good security solution, we either give a very good one, which is skill, you can use it, or you can provide the analysis for people to say, hey, you do this matrix calculation and it looks good to you, then you can do it. But I would not feel comfortable with the latter option because I don't know how to do that calculation correctly because it keeps changing and it's so many places here. You cannot do that. There's no chance to do that right. And in this day, we are a really important organization to provide security solution and recommendation, and that would be very dangerous for us to go.
Yeah, that's a good perspective to keep in mind. Okay, Dave?
Dave Taylor, thank you for putting up this slide so we know where you're going next. And I like this slide because it says it's asking about a solution and not taking into account the details of any particular solution at the context of these questions. So these are good questions, and I wanted to potentially suggest adding of another question, which you might think of as splitting the first question into two, because I want to distinguish at the question level between low security systems and single role systems. Okay, because you can have a high security single role system and so on. So I might suggest you ask those as two separate questions, because low security might say, very few bits of entropy by comparison to something that's high security, right? Which is completely independent of whether it's one role or multiple roles. And so I would find it useful because I might actually hum differently if the question was phrased that way. And so you might ask both ways. Are low security systems a case that should be solved in the IETF, and are single role systems a case that should be solved in the IETF? Are two different questions, is my point. You might hum the same.
I'm going to make a suggestion to resolve this, something that I think might actually split the baby in half, if you will. The current document with respect to multicast, group key multicast security contains both symmetric component and an asymmetric component. Publish that document with both of those mandatory. Then publish a second document, which is a lighting profile, which releases which basically relaxes the mandatory for that particular domain, specifically for the lighting case. That way we get a document that says, no, we don't publish low security systems in the IETF. The profiles tend to be a little bit things, you now talk about it in terms of tiny little IoT devices, and we are looking the other way on security for a lot of those. So.
So Kathleen Moriarty, AD. I like that suggestion. The only problem I have with it is when you do profile documents, and maybe you have an answer to this, if we are stating must and must, so mandatory to implement on both of those, then the profile has to have that must as well. So what do you propose for the flexibility that you're suggesting?
Can't take away a must. Yeah, can't take away a must.
That seems to be kind of a weird rule because we've been doing similar things, I thought, with respect to, for example, when we were talking in the DICE group about taking things out of TLS or DTLS for the DICE stuff. And I got to tell you, there was a lot of...
Hannes, I can't hear you.
So, yeah. So we don't take the musts out in practice. I've been down this exercise. What was that?
Even as informational.
Well, see, we would even come down on other SDOs for this, and I have direct experience with that. So, yeah, I mean, I spent 10 weeks of my life going to a particular SDO to make sure the profile rules were adhered to. So, that's right, that's right. There were some nice things about the city, I won't mention it. But if you have, or if others have creative ideas along that line, shoulds can be bendable in that way, but musts can't. But it's an interesting approach to get us further, and making progress here would be so nice. We've been talking about this for well over a year.
So there are still several people on the mic line, but I do also want to get some hums done. So are you really burning and jumping up and down to say something?
Yes, this is Dave Robin. Just want to define what low security means, because I can't if I don't know what that term means. Are you talking about algorithms and bit lengths and key distribution mechanisms, or are you talking about simply symmetric versus asymmetric, i.e. What happens to a compromised device? That's right. I'm agreeing entirely with Dave Taylor. Privilege escalation, compromised device. If you have a symmetric system, a door controller can pretend to be the authentic, the controller and issue commands to other door controllers. However, let me say that that's okay. You have to understand that a single device can have multiple security domains in it, and the controller that sends out things like day mode and night mode, that's a multicast that can be a symmetric key, and that it can even be compromised, because as we go back to our original slides, it's not devastating if you compromise that. It's annoying. Somebody walks up and goes, oh my God, my key doesn't work. I got to go get somebody to let me in because this stupid thing thinks it's in night mode. So that's okay if somebody compromised that. It's not disastrous. But the fire control system that says, open the door, damn it, that is an asymmetric, not symmetric mode. It's another role within that device, and it's never shared. It's a one-to-one with the main fire controller. So it's okay that you can have two different kinds of security within the same device, but they might be using the same exact, DTLS or key length or whatever. That's not what we're talking about. So I need to know what low security means in order to know how to vote on that. So yes, I think we produce low security in that you consider symmetric to be lower than asymmetric.
Yeah, so I think the intent here is low security in the sense of the consequences of compromise are minimal and not in any sort of like bit strength question.
Brian Wise, Cisco. So the one comment on that, well, oftentimes we think about for group security systems, what are the threats to those? And we're willing, for example, maybe to say a low, quote unquote, low security system is the group level security with symmetric keys, because at least we believe that it takes somebody to, assuming we have a strong authentication system to the key server, then at least it takes somebody to do a physical attack to get the key material out. Okay. My real question is on the third bullet. When you say authentication, you mean authentication and the use of symmetric keys? Because I would hum very differently if it was just authentication.
The third bullet could actually be either symmetric or asymmetric, as far as I'm concerned. It is just having source authentication of some type.
The source authentication in the data packets.
A single source authentication, not a group source authentication. So I would consider Mike's. I'm going to send multiple Macs, each authenticate with a different key for a different person, to be an authentication solution.
Okay.
Not necessarily a great one, but a solution.
Johan Selander. I think the second question is source authentication compromise detection a requirement? I mean, it may be optional to support in certain use cases, but the solution must support source authentication. So I think that's rather than a strong desire, that's mixing the two cases where we want to have low security and we want to have source authentication with the same solution. And another comment, if I may take it. I think that Mike's proposal of having a solution which supports both and where you make an exception is a possible way forward. So I think that's a possible, Hannes is disagreeing, but I think that's a possible solution, that we actually did something similar in the COSI document. So in the COSI, if you recall the COSI document, the algorithm is mandatory. But Appendix A describes an exception, and under certain conditions, you don't need to provide the algorithm in the COSI object. So I think that's an example of how this could work, that you actually have a description of how to use source authentication, and then you make an exception either in a separate document or in an appendix.
I'm going to cut the mic line so we can get to the hums after these.
Carsten Bormann. I'm a professor, and I must admit I give low security lectures. I don't have an armed guard at the door that protects me. And I kind of feel comfortable with that. My students do too.
Hi, this is Henk. This is from a, I don't know, I think cross STO point of view. I heard the word compromised thing a lot in this discussion, and apparently secure means that's not compromised. And I think therefore everything here is low security, because proving that something is compromised is kind of really difficult. And so I think the scope of the question depends on better defining what you think is secure. You're talking about keys and asymmetric and stuff, but a thing being compromised is not the thing we are talking about here, I think. We can't, because we cannot show that it is compromised or not compromised. And I think that's dangerous to assume, because we're talking about light bulbs all the time. You can see that it's going off and on, because you can see it. This is a bad example. Most things are not, you cannot see if they're compromised. And proving that they are compromised is pretty much out of scope of this SDO here, I think, mostly. Yet.
Sam Weiler echoing something I think I just heard in a slightly different form, which is we really need to pay closer attention to requirements. We were just giving an example of a device we care a lot about, of a fire door, and people saying, well, we care about whether it gets a fake command. We may actually care less about it getting a fake command to open than it not getting a command. So being the difference between an inauthentic and an undelivered command, they have very, very different requirements for us.
Yeah, and of course the reliability question was raised already and is mostly out of scope here. So if we can get to the hums, I think I will take the suggestion to split up into separate questions about low security versus single role. And so if I want to consider low security systems as those where the consequences of security being broken are minimal in the judgment of the owner of the system, let's hum. I'm going to do hum for yes and no. Are these low security systems a case that we should be addressing in the IETF? If you think yes, please hum now. If you think no, please hum now. I think I'm hearing slightly stronger no's than yeses. Slightly louder, perhaps not necessarily number. Okay, so next question. So now instead of low security, let's talk about these single role systems where all participants have the same privilege, and a compromise of one compromises the entire system. So we think that sort of system is a problem that we should address in the IETF. If you think yes, please hum now. If you think okay, so the minute taker has expressed concern about being able to accurately represent the question being asked. So if I can try to clarify, the point had been raised previously that there's a qualitative difference between systems where there's one role and one level of privilege versus those where some actors have different privileges than others. And so the particular type of system that I want to ask a question about is one where every participant in the system can send messages, and there's no distinguishability between who is sending the messages. You're either in the group or you're not in the group. So you're in the system or you're not in the system. If you're in the system, your messages are assumed to be valid. If you're not in the system, your messages are supposed to be ignored. Nancy, does that help you? You're still confused?
What you're describing is what you're describing is a type of system design, and the question is whether this kind of system design acceptable to us is something we want to describe, or if that is, or do we? Well,
yeah, I guess the question is,
that's not really a good question.
Do we consider this type of system flawed?
Yeah,
is sort of what we're asking.
That's a confusing question.
Well, okay, so I may have completely, okay, the way I'm capturing the question in, oh, okay. You don't want me to go away. I just heard go away. Okay, so, so the way I'm capturing the phrase is basically every participant in the system, when they send a message, the receiver cannot distinguish who the sender is.
This is question number 2.
Well, I thought we were humming on question number 2.
No.
Well, the preface,
You're humming on the question, it's not on the screen.
which is as a note taker, I'm asking, what are we humming to?
The difference between question number 2 and this question. Question number 2 is the source authentication question. Question number 1, part 2, is whether or not all the participants in the system share exactly the same level of privilege. Okay. So the question is
Mike.
Oh,
Okay,
sorry.
you might.
Sorry. So the question is, part 2, is in an interest of this group to work on a system where the characteristics of the system where all members of the group share equal privilege. So the compromise of one group, of one member, does not result in any additional privilege elevation. Is that fair?
Basically, yeah. I mean, I'm gonna restate the question before I call for the hums.
Can we put that up? And I'm wondering if we can redo all the hums, and I will stand on that side just in case there's any difference in the room. I have found in the past that it helps. That's why I walk around if anyone wonders. Plus, it's nice to get out of these uncomfortable chairs.
I've got to restate this? Okay. So
no, I think we're gonna write it up.
Okay,
in
so
text on the screen.
so she wants to do the whole thing over again. Let me try with the low security hums. The low security case is a case where not all devices share the same privileges, and the compromise of one device allows for privilege elevation, allows you to gain privileges you you shouldn't be getting. Is that fair?
I don't think that was the question I tried to ask the first time.
Okay. Well, okay.
Yeah, I mean, it's always a challenge to make sure you ask the question that you're actually interested in. Jim is typing in a window that is not on the projector, yes. Yes, okay, and so the other one is going to be in systems where a breach of security is deemed to have minimal impact by the owner of the system. Do we want to address that that type of system in the IETF?
Sorry, are we redoing now? It's 1A we are doing now. That's one. Okay.
we are going to redo 1A and 1B, and we've got new text that's because if the window is visible on the projector, then Jim can't look at it as he's typing, and it's important to be able to see what he's typing as he types.
I don't type this way.
Okay, so back to, I guess this is 1A. So do we want to address in some way systems where a breach of security is deemed to have minimal impact by the owner of the system? Is that still unclear? Okay, so I'm going to just do hum for yes, hum for no. So if you think that yes, we should address this type of system, so hum yes for now. And if you think we should not address this, please hum now. So I'm still hearing louder no's. Okay, so onto the next one, bullet point 2. So if we have, can we move on to the next one, please? Okay, so if we have systems where all devices share the same level of privilege, and the compromise of a single device does not grant any more privilege than that device already had, is that a type of system that we want to address in the IETF? Please hum now for yes. And please hum now for no. That is very clear. And the final one, do we believe that unique source authentication is a strict requirement for work in this space? Please hum now for yes. So unique source authentication would mean that for any given message, you can state with confidence, within the parameters of the crypto system, who was the originator of the message. Who's the sender?
I'm happy to hum on this. I'm just realizing there's two different interpretations of that question, and I will arbitrarily pick one and hum for the one that I think is the one that I want.
Yeah. Okay.
I'd rather not arbitrarily hum. I'd like to know if it means, as we discussed before, that source authentication should be part of the solution, but not necessarily to use.
No. Okay, quiet except for the humming, so hum now for yes. And hum now for no. It was very weak in both cases, presumably because we don't like the question. No, it's very clear why it happened. Right. We need to move on. Yeah, we're basically out of time. We have 2 minutes. Oh, right, but we lost focus on the slides. Okay, so to wrap up, we have various things that we want to get done before London, and something in group communication might be of that. But we definitely want to advance on the CWT work and hopefully the proof of possession, because we think that's in good shape. We also want to work on the core framework document and try and get that to working group last call. Of course, it doesn't mean the working group last call would be passed by then, but get it to that point. We do want to have an adoption call, make a decision about group communication, and we got some input from the hums. And then the EST work in a similar situation. And also for the multicast, we want to try and get a sense of should we adopt this work or should we not adopt this work in the next few months.
His microphone was cut off. We ran out of the meeting. This Cool. works. That's so Ben and Jim, what should we take out of, what is my takeaway? Tell me what my takeaway from the group communication security discussion is supposed to be. Like, I have to tell folks in my company what the story is now.
I mean, I think there was pretty clear support for having some solution for this case where all devices have the same level of privilege. And if I understand correctly, that's the sort of thing your company is looking for. I don't know if it's going to be your document or not, but something.
So I just have a comment here, and I don't understand the difference between the group communication and the multicast work, but is there any difference there? What is
right? Well, so
they're all addressing the same scenario.
We have the asymmetric and the symmetric stuff, and right now they're different documents.
Okay. So I'll tell you what, this is Elliot. I'll tell you what I'm going to take from that hum, or those series of hums, which is, we didn't make really much of a decision here, but rather that the people who are working on documents need to listen to those hums and try and navigate a way to find consensus to move the documents forward in terms of the interpretation. But I'll say this, I was talking to Dan in the back there. One of the things I think that would be very helpful as we go through all of this is that in each of the documents, a clear threat model is defined so people understand what they're getting and what they're not getting in each case. And if the documents are attempting to be comprehensive, right, then you say, well, with this option you get this, with this option you don't get this, and that addresses these threats. And having it tied to that, I think, will help us in London move forward.
I agree. I think that would be helpful. And of course, people can probably read the slides. Do we have interest in another interim for any of these topics or a hackathon? Actually, we would like to have a hackathon on the core framework so we can get a better understanding of what the needs are and how it's going to work, and if we need any more changes, because we would really like implementation experience on the core framework so we can get a better sense of how close to done it is. And I think we are over time at this point, so we have to let you go. Thanks, everybody. If you did not sign the blue sheets, please find the blue sheets. Raise, where are the blue sheets? I see one blue sheet. I see two blue sheets. Excellent.